So hello everyone, this is Easy Automation here and today we are going to talk about that one thing which can make your program more efficient and optimized. So let's talk about the memory bits or bit memory, whatever you want to say. So let's begin. So the bit memory or the memory bit is the binary bit which can be used for temporary addressing of any instructions like input and output, and it can be used for triggering instructions as well. But mostly memory bits are used whenever there is involvement of SCADA or HMI in the overall program logic. So if you want your program to be more optimal, then these bits will be more useful in those cases. So now let's get some idea how we can use these memory bits. So to use these memory bits, I will create one small program here which has just basically one YANO contact and one output coil. So I will just use here B3 colon 0 slash 0 enter, and you can name these bits as well. I will name it as start, and for output I will use another memory bit B3 colon 0 slash 1 enter. So for this one I will name it as bulb. So as you can see, I have used here one memory bit for YANO contact and one memory bit for output coil. So by this example, you can get the better idea that we can use these memory bits for input and output instruction addressing. So let's check. Our program has no errors. So now our program is in running condition. And if I toggle this bit high, then our output will go high. And if I untoggle this bit, then our output will also go off. So this is how you can use these memory bits for inputs and outputs in Allen Bradley. And now let's create one another program so that you can get better idea about these memory bits, like how we can use these for temporary addressing of inputs and outputs. So for that one, I just need one branch instruction here, and I will just add one YANO contact here and one another here and one NC contact here, and I will just add one another rung here, and I will just add one YANO contact and one output coil here. And now let's delete this one. So for this YANO contact, I will be using input address I colon 0 slash 0. I will name it as start. And for this NC contact, I will use one another input address and name it as stop. And for this output instruction, I will just use the memory bit B3 colon 0 slash 0 and name it as holding. And I will just copy this bit address to our YANO contact here, and I will copy this here as well. And for this output instruction, I will give address of the real output, that is O colon 0.0 slash 0, and I will name it as motor. So here in this program, I have used two input addresses, one output address and one memory bit for holding. So now let's check this program. So these inputs are the actual inputs which are present on the terminal box of the PLC, and this one output is also present on the terminal box of the PLC, but these memory bits are only being used in inside the program, but these are not used in actual input and output manipulations. So whenever I want to turn on this motor, I will just toggle this start input and I will remove this one, but our motor is still on because I have used one bit memory here for holding, and by which our motor is still on. But if I want to turn off this motor, I just need to toggle this another input. So by toggling this NC contact, our supply will break here and our holding will cut off here and our motor will stop here. And if I untoggle this one, then also our motor is off because the holding has cut off. But the main concept here I want to emphasize, that is bit memory. So I have used one bit here for holding, which is the replacement of output coil and input instruction. And if you don't know about these memory bits, you will just use one output address here and you will just copy that address here as well. And that's how you will end up your program. But if you want to turn on this motor from any SCADA or HMI, you need to use the memory bits. So now let's talk about that concept. So we are offline now, and for operating this motor from HMI or SCADA, I will just use one branch instruction here. I will just extend take this branch up and I will add one NO contact here, and I will just add one another NC contact here in series with our first NC contact, which is our stop push button. So I will just use here another memory bit B3:0/1, and I will just name it as SCADA stop. I have just named it as SCADA stop. So whenever I want to stop this motor from SCADA, I will just toggle this bit high, and for turning on the motor I will just use here another memory bit and I will name it as SCADA on. So whenever I want to turn on this motor from SCADA, I will just toggle this bit high and our motor will start here. So let's check this program. Let's consider our first condition in which we are going to operate our motor from manual operations like from the push button. So imagine this start is the push button and I will just push it on and release this one. Then our motor is on, and if I want to turn off this motor by another push button, I will just push this button on and release this one. So our motor will off here. But if I want to turn on our motor from push button and turn off from the SCADA. So let's turn on this motor by using push button, and to turn off this motor I will just use this memory bit which is being manipulated from SCADA. So whenever the operator toggles the bit from SCADA screen, the bit will get toggled and our motor will go off, and whenever he untoggles the bit from the SCADA, the bit will get its initial condition. Like here in this case it will become NC again. And if I want to turn on this motor from SCADA, the operator will toggle this bit high and our motor will start, and whenever he releases his finger from the screen, the bit will go off, but our motor is still on because I have used here one holding. And if the operator wants to turn off this motor from stop push button, he will just push this stop button and release this one, then our motor will get stopped here. But the main concept here is memory bits. So by watching this problem, I think you have got some idea about memory bits. Like these memory bits are mostly used where there is use of SCADA or HMIs in the program. So whenever you want to do any operation from SCADA, you will need to use these memory bits for temporary addressing or to replace the inputs and outputs so that your project cost will be reduced. So this was the overall idea behind these memory bits. So I think you have got the point and took the notes. And if you didn't got any point in this lecture, you can simply ask in the comment section. I will always be there to answer your questions. And if you learned something new, make sure to hit that like button and share this video to your friends and colleagues, and subscribe if you are really interested in automation. And don't forget to check my previous videos so that you get better understanding about PLC programming. So with that being said, I will see you in the next video in which I'll be teaching you more interesting concepts of Allen Bradley or PLC programming. So stay tuned and stay subscribed. Bye.